Let's start the sums in friction. As I said, there are 5 types, and let's start with type 1. Examples based on belt friction. In this type, this formula is very helpful, which is T1 by T2 is equal to e raised to mu theta. Here T1 is tension on tight side and T2 is tension on tight side. E is a constant, mu is coefficient of friction, theta is angle of lap. Let's start the sum. Maximum tension that can be developed in belt is 600 Newton if pulley A is free to rotate and coefficient of friction at fixed drums B and C is 0.25. Coefficient of friction between pulley and belt is 0.25. Determine the largest mass of block that can be lifted. So we have to find the largest mass of this block that can be lifted up. Let's start. First we have to draw FBD of pulley. Pulley B, suppose this is pulley B. Here the rope is hanging like this, and here this is pulley C. Here it goes like this and this. At this both end only tension T1, one value of tension will be there because this is free to rotate, and here it is W and T. If we are pulling this belt from this side, obviously this will be the tight side and hence this will be the slack side. So this is tight side, this is tight side, and hence this is slack side. As it is tight side, this will be the slack side, and as this is slack side, this will be the tight side. Tension act on this belt is T1 only. So let's start the sum. First we have to decide the angle theta. We have to measure it. If we consider this as right angle triangle, this is 45 degree. If this is 90 degree, this will be the 45. So theta is equal to this 90 plus this 45. So theta is equal to 90 plus 45, which comes 135 degree. And if we have to use this formula, the theta must be in radian, and we have to convert this into radian, and hence we are going to multiply it with pi by 180. It comes out 3 pi by 4. Okay, then if we consider this as a system, this only, T1 tight side, tension on tight side, so T upon tension on slack side, T1 is equal to e raised to mu theta. We have given that maximum tension that can be developed in belt is 600. So in the whole system, this is the tight side. So we will consider T as 600 Newton. So 600 divided by T1 is equal to e raised to mu. Mu is given as 0.25. 0.25 into 3 pi by 4. Here unknown is T1, and we'll get T1 as 332.9 Newton. we have the value of T, and we just got the value of T1. Now from T1 we can calculate W, and hence we will get the mass of the block. Now we'll consider this as a system, and we apply this formula. Here tight side is T1, so T1 upon slack side is W is equal to e raised to mu theta. Here T1 is 332.9, W is m into G, G is 9.81, e raised to mu 0.25 into theta 3 pi by 4. Here unknown is m, and we'll get m as 18.83 kg. They asked largest mass of block, and this is the 18.83. We'll see next sum. Force P mg by 6 is required to lower the cylinder with the cord making 1.25 ton around the fixed shaft. This is P. The rope is making 1.25 ton around the fixed shaft. Determine the coefficient of friction mu s between cord and shaft. Okay. Now in this kind of sums, we have one formula only. T1 by T2 is equal to e raised to mu theta. So T1 by T2 is equal to e raised to mu theta. Here we have to find out mu. We have to find out this. Theta is, we need to calculate, theta is, the rope is making 1.25 tons. 1.25 tons. What does it mean? One ton is equal to 0.1 ton is equal to 2 pi in terms of radians. Okay, so if what is pi? 180 degree is equal to 1 pi in radian. This is, it is making 1.25 tons. Matlab, what does it mean? 1 ton is this, and again 1.25, so this much. This is pi, again this is pi plus pi, 2 pi, and then pi by 2. Pi plus pi plus pi by 2. It comes out 2.5 pi. 2.5 pi, or you can directly do multiplication. 1.25 into 2 pi, it will come out 2.5 pi. Okay, hence you got the value of theta. T1, tension on tight side and tension on slack side. If we are applying force at this side, this will be the tight side, and obviously this will be the slack side. Tension on tight side is P. We have T1, T2 is weight is mg. So we'll put the values. T is, we have given the value of P, mg by 6, mg divided by 6 divided by T2. T2 is weight of this cylinder, which is mg. then e raised to mu theta. Mu is, we have to find out mu, and theta is 2.5 pi. Now mg, this mg and mg will get cancelled, and it will be 1 by 6. 1 by 6 is equal to e raised to mu into 2.5 pi. Here unknown is mu, and you will get mu as 0.23. They asked us to find out coefficient of friction between cord and shaft, and this is the answer. We'll see the next sum. Determine the range of P for equilibrium of block of weight W as shown in figure. The coefficient of friction between rope and pulley is 0.2. Okay, here in this numerical, they asked us to find out range of P. Range. Okay, so let's see. Here there are two cases. This is the pulley. This at this, from this end we are going to apply the force, and this is the block having weight W. So we have one formula only. T1 by T2 is equal to e raised to mu theta. Here case 1, here there are two cases. If P is greater than W, if P is greater than W, this will be the tight side, and if W is greater than P, then this will be the tight side. So we'll consider both cases and we'll find the range of P. So in case 1, if P is greater than W, so this will be the tight side. Tight side upon slack side is equal to e raised to mu theta. Here theta will be 90. Theta will be 90. By observation you can say that if this is pi, this entire 180 means pi, and 90 means pi by 2, so theta is pi by 2. So we'll get theta is equal to pi by 2, and mu we know that 0.2. Weight is weight, they did not provided us, they did not give the value of weight, so will not consider the value, will not put the value. Here P by W is equal to e raised to 0.2 into theta is pi by 2. Here we'll get some value of this expression only. It is 1.369. okay, and the W will go here, and expression will look like this. This is the expression. If we consider the case 2, case 2 is if W is greater than P. If this W is greater than P, then this will be the tight side and this will be the slack side. So tight side upon slack side is equal to e raised to mu theta. Same we'll have by calculating we'll get the equation. This will be the in this case, in case 2, W is greater than P, so the value we are going to get by this case will be P minimum, and if this is tight side it will be P maximum. So this is P max and this will be the P minimum is equal to 0.73 W. They asked us to find out the range of P and we got P maximum is 1.369 times W greater than or equal to W greater than or equal to 0.73 times W. This is the range of P which they have asked. We'll see the next sum. Determine the minimum coefficient of static friction between rope and fixed shaft as shown in figure will prevent the unbalanced cylinder from moving. Okay, then they asked us to find out coefficient of static friction, that is mu. We have one formula, T1 by T2 is equal to e raised to mu theta. Here T1 T2 is given, E is constant, mu we have to find that, and theta for theta C will draw FBD. This is cylinder 1, cylinder 2. This is 100 Newton and this is 50 Newton. As 100 Newton is greater than 50 Newton, this will be the tight side and this will be the slack side, and the angle between them is 180. In radian it is pi. So T1 tight side, tension on tight side is 100 Newton upon T2 is 50 Newton is equal to e raised to mu. Value of mu we have to find that, and theta is pi, and hence we'll get the value of mu. Mu is 0.22. These are the sums of type 1.